So let's quickly recap, okay, what we did last time when we started the radical, right? So first, we talked about what is a perfect square, right? Something that has square roots, right? And then it does not go on forever, right? So something that's not perfect square is like 12 because you cannot find a number exactly squared and equal to 12. And 16 will be a perfect square because 4 times 4 is 16, right? Exactly 16. Even with decimal, you could also have a perfect square. Okay, so like for example, 0.04, right? Or 0.81, you can 0.36, right? 0.36 is also perfect square, like question A there. It doesn't have to be a whole number, right? It could be a decimal too. And then we talked about there's always two square roots. If they say, please find the square roots, you always have a positive and a negative. Okay, so the positive, you just put a square root sign. So for example, like question 1a, right? Square root sign, the radical sign 25, that's the positive. Okay. Yeah, so this one is the positive radical, right? So give you the positive square root. And then you could have a negative radical 25, like give you the negative root, right? So you always have two square roots. But when you get a question that tells you to evaluate, you don't need to put plus minus because the question tells you, like question A, it tells you it's the positive radical, right? So your answer is just positive 0.6, okay? And if you look at question F, it tells you that it's looking for the negative, right? So your answer will have a negative at the front, okay? Negative square root. So different, okay? Depending on what they ask, question 1 is asking for square roots. You need 2 of them. Question 2, it only asks for 1 of the roots, okay? And then next thing is the difference between these 3 expressions. So in fact, they are all the same, okay? So the conclusion we reached last time is when you see a square, the one in the yellow highlighted right now, square meets a radical. When they combine together, it does the same as the absolute. So this is called the absolute value. So it makes whatever that's inside the absolute value or the brackets become positive, okay? So if I have absolute value of -3, or just make it equal to 3, right? So it does the same thing as 1 and 2, right? Inside is positive, it stays as positive 3. Inside is negative 3, also called as positive, right? So these two, number 1. Number 1 and 2 give you the conclusion at the bottom, okay? Positive 3. Right, so if you compare, right, number 1 is using the 3 on the inside, number 2 is using -3 on the inside. So it does the same thing as absolute value. So just a way to simplify the expression, right? And then on the next page, we talked about the 2 conditions that's required to check if the radical is simplified or not. All right, so Brendan, what is the first condition?
Sorry for what?
What's the first condition for a radical to be simplified? How do you know a radical is simplified or not?
If it's a prime number.
Can you say that again?
If it's a prime number, if it like doesn't.
Okay, prime number, yeah, but not always, right? It doesn't have to be a prime number. Prime number for sure is not simplified all the time, always, right? But it's not for all the, like some non-prime number are also not simplified. So we need another rule, right? What's the rule to check?
When it doesn't have like a perfect square inside.
Yeah, or a perfect cube, okay? Depending on the radical they give you. For example, like question 3C, right? 3C, you have a 24. 24 is not a prime. But because 24, I can break it down into 4 and 6. But 4 is a perfect square, so we know it's not simplified. Okay, so this is what we did last time, right? How to identify which one is simplified, which one is not. Okay, yes means it's simplified, right? If you look at example B, it's simplified means you don't need to do anything, right? And then question E, right? 34. 34, if I break it down into 2 and 17, none of the numbers are perfect square, right? So you know it's already simplified, okay? And then what's the second condition now, Nathan?
Pardon?
What is the second condition for something that's simplified?
There's no radical in the denominator.
Yeah, okay, so you also want to make sure you don't have radical in the denominator. Right, if there's a radical in denominator, like question 2, example 2 on the right side, then we need to find a way to make the radical disappear in the denominator. Okay, so those are the two things you need to check. You need to make sure no perfect square inside, no radical in denominator, two things. Okay, if the question has a cube root, then no perfect cube inside. Okay, so today we're going to learn how to simplify things, right? If it's not simplified. So let's start with the next page, okay? Page 23. So 180, right? Square root of 180, right? So this one is a pretty big number, so very high chance that it's not simplified, right? So the way we can check this is to see if there's any perfect square. So we take 180 and then do the prime factorization, okay? So the way I do the prime factor, of course you can do the tree, right? The 180 and then you split, right, into primes. But I like to use the boxes, the stairs. So then it doesn't spread out too wide, right? It takes up too much space. So I will start with 2, okay? Only use prime numbers. And then divide by 2, that's 90. Can divide by 2 again, right? So that will be 45. Okay, so what's the next prime number I can divide? Eric?
5.
Yeah, 5 will work. Okay, so 5 will give you a 9, and then 3. Very good. So as you can see, we have perfect square here. The 180 is made up by 2 times 2. That's a perfect square, right? Because that's a 4. Times it by a 5. Times by 3 and 3. So that's another perfect square, right? This is a perfect square here. That's another perfect square. That's why I know we need to simplify, right? You cannot have perfect square inside. So if it's multiplying, we can split up the square roots, okay? So it becomes square root of 4, right? Because 2 times 2. square root of 5, and square root of 9, right? 3 times 3. I split up into the 3 of them because you have 2 perfect square inside and 1 of them is not. Okay? And the reason why we do that is when the perfect square meets a radical, it cancels each other out. So it just gives you the 2, right? And then the square root of 9 just becomes a 3. So radical disappear. The only thing that's still left inside is a 5, and that is not perfect square. That's our goal, right? And give you a 6. So your final answer look like this. But this takes too long, right? You can see that it takes me 4 lines to get to the final answer. So the way I can do this faster, I want to go straight to here. Okay, so what you need to do is you just look at the table here, the square table, and then you see from the chart, you have a pair of 2, right? You can see it from there. A pair of 3. So when you see a pair, they will go outside, right? That's why I call this perfect square outside, right? You take out all the perfect square and put it outside. So 2 goes out, right? 2 goes out, 3 goes out, 2 and 3, they multiply together, make the 6. Okay, so this is if the question has a square root, then you do perfect square outside. If the question has a cube root, then you would do perfect cube outside. Okay, so depending on the question. So now I would like you to try question B. Okay, question B has a cube root. So we need, instead of pairs, we need triplets. Okay, every triplet is a group, you take it out. All right. So please complete the table, right? The stair, okay, factoring. And then take whatever that makes a triplet, make it go out, okay? And I'll check your answer when you're done. You can raise your hand, okay, when you finish. Just question B. You do not need to do so many steps, okay? Like question A, you just finish the table, this factoring squares, the stairs, okay? Factoring stairs. Those are called that's called the prime factorization. And then use that to figure out what goes outside. Okay, if you finish B, please raise your hand. For numbers that's bigger, like 540, of course you can use something bigger number, right? Not prime. For example, you could use 10. then that brings down to 54, right? But then you might miss the triplet, right? Because inside 10, right, the 10 can continue break up into 2 and 5. So if you only look at the number 10, right, you might think there's no triplet, okay? So it'll be better that you use prime numbers only. Okay, Nathan, do you have any questions? Yep, okay, so Aaron, can you tell us what numbers you used for the factoring?
The first one was 2.
Okay, so 270, go on.
And it's 2 again.
So what's that? 135. And then?
By 5.
Yeah, so that will be
27.
Yeah. So 3933.
Yeah.
Okay, very good. And Nathan, what's your final answer then?
Is it like 3 on the outside and 20 on the inside?
20 on the inside, and then?
And like a square root around the 20.
Like that?
Yeah.
Okay. Any questions here? Is there any mistake? Anything we forgot? Did everyone have the same? Then everyone gets a little mark off. What did we forget?
The cube root on the 20.
Cube root, very good. Okay, so you have to remember that this question is a cube root. So we need to keep the cube root. Okay, this is a common mistake. Right, because you are so used to the perfect square, you take perfect square out. When you take the perfect cube out, don't forget it's a cube root question, right? So keep the cube root. So this one, let me just show one more step, right? So cube root 540 can become 2 squared times 5 times 3 cube. And this is a perfect cube. So it goes out and put it outside. Whatever that's not enough to make the triplet, it just stay inside and they multiply, okay? So that's our final answer. So easy with numbers, right? Let's take a look at what do we do if there's a variable inside. The idea is the same. First thing you need to know, this is a square root or cube root, right? We have no number here, right? So this one is a square root. So we are looking for pairs. I'll do it slowly first. So same thing, we need to turn it into factors. You already have something on the outside, so they are just waiting, okay? And then we break down everything on the inside. The 8, okay? How do we break down the 8, Eric?
It's 2 times 2 times 2.
Yeah, very good. Okay, so 8 will be 2, 2, 2. Or I just write, yeah, I'll write it all out. Okay, 2, 2, 2, not too many. Extra 7, that means x, 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 right? So 4, 5, 6, 7. And then for the y, we have 1, 2, 3, 4, 5. Okay, this is for explaining, okay? But you don't need to do this every time, right? And they put extra 70, you will spend the whole hour writing out 70x and miscount it and start over again, right? This is a perfect square. We need pairs, right? So this is a pair. So that will go out, right? 1 pair, 2 pair, 3 pair, right? Because 7 of them, you can make 3 pairs. So they all go out. And then for 5, right? Y to the 5, you can make 2 pairs. If it's a cube root, you need triplet, okay? This is a square root, you just need pairs, twins, right? So when they go out, they will meet, multiply with whatever that's already outside. Right, so 2 will go out, but there's no number outside, so just put a 2. You have x go out, right? 3x go out meets the x on the outside, so that makes a total of 6 of them, right? Because you get 3 of them going out to join the 3 of them outside, right? And then for the y, on the outside already has 1, right? And you get 2 y's coming out, so that makes 3 on the outside. Make sense? Okay, and then the leftover, you just write down whatever that doesn't pair up, right? So you have a 2, x, and y. So you want to think about how we can get here directly, right? Because we don't want to write it all out, right? So you just look at the numbers, right? 7, because the square root, so you divide by 2, right? See how many times the 2 can fit in. So you get 3 of them. Same with the 5, right? When you divide by 2, you can only fit 2 pairs. And the 8, if the number is big, then you draw the staircase, right? The prime factoring. If number is small, you can just figure it out in the head. Okay, does anyone have questions? Okay, so we don't need to show a lot of work. All you need to do is draw the prime factoring, okay? Then you should be able to get the answers. So that will be the 3 kinds of questions you need to know, right, for this page. So I'll let you guys to get to the questions now, okay? So you can finish everything on this page. Each one of you will get a chance to answer a few of them, okay? Let me see. Yeah, everything should be fine. Like look at question I and J. They have numbers outside, right? So whatever that comes out, it will multiply with the number on the outside. Question K, question L, they have 4th root, right? So think about what does it take to make it go out, right? If there's a 4th root. Okay, pay attention to question O. Question O, the cube, this is a cube root, okay? The cube is not for the z. So be careful, this is a cube root. Right, so how do I tell it's a root or exponent? You look at the typing, right? If it's with a z, it should be higher, and then it'll be empty for the square root, right? If it's square root. So because the cube root, they moved it down, right? Then we know it's a cube root, not an exponent, right? So be careful when you read the question. So that could be tricky in that way, right? So not your fault, but just remember this could happen. All right, so let you guys get to it. If you have any question in between, right, let me know. This should take about probably 10 minutes, 10 to 15, okay? So we'll check answer when you're done, okay? Raise your hand if you finish earlier. Okay, just checking on your progress. What question are you working on, Eric?
I'm on J.
Okay. And Nathan?
I'm on I.
All right. Okay, Eric, what number?
I'm on N right now.
Okay. And Nathan?
I'm on N.
Okay. Okay, let's start getting some answers first, all right? So we'll start with Aaron. What's your answer for A?
2 root 3.
Okay. Brennan, next one.
3 root 6.
3 root 6. Okay. And Sarah? C.
12 root 2.
Okay. Eric? D.
3 root 5.
Nathan? E.
6 to the square root of 15.
Root 15.
Yeah.
Yeah, okay. Aaron? Next one. Aaron.
10 root 3.
Yeah. Okay. Brennan?
3 root 10.
Sarah? Sarah?
3 and
Yeah.
then like cube root 2.
Cube root 2. Okay. Eric? Eric, next one.
I'm not sure, but I think it's -16. And then,
Cube root.
wait, hold on, give me a second. I think it's actually -36 and then root 3.
Okay. -36 cube root 3. And then cube root of what? 6 or 3?
3, I think.
3. Okay. And Nathan, J?
I got 10 to the cube root of 2.
Cube root 2. Okay. Let's back to Aaron. K?
2 4th root 4.
2 4 root 4. Okay. And L? Brennan?
2 4th root 2.
2 4 through 2. Sarah?
5x squared yz square root of 3xy.
5x squared yz and then square root
3xy.
3xy. Okay, Eric?
I'm still working on this one.
Okay. And Nathan, how about you? Question N?
I'm stuck on that one and O.
Okay, okay. Then we'll go over N and O together, right? So please, everyone, check the answer on the sheet on the screen right now. Does anyone have different answers?
I have a different answer for I.
Yeah.
For I, okay. What's your answer for I?
I got -12 cube root 4.
Cube root 4, okay. Anyone else? Any other ones have different? Okay, so just I, only I has different. Okay, so I'll quickly go over the answers, okay. 12, right? 12, I can break it down into 2, 6, 2, 3, right? So you can see 2 goes out, okay? So that's correct, right? Takes 2 seconds. Next one, 54. So you can do 2, 27, 3, 3, 3. So you get a pair of 3. 3 goes out. 6 left inside. Perfect. Okay. 288. I'm going to cheat a little bit. Okay. So what I'm going to do, I use 2. Right. So 144. And then on the back of my head, I know 144, I can make a pair using 12 and 12, right? If you know your perfect square well, you can do this cheat, right? 12 times 12 makes 144. 10 times 10 is 100, right? Those things you can bring it up if you know, right? Or like 11 times 11 is 121. Those are perfect squares, right? So if you want to memorize like that, you could also use it. So you can see there's a pair. So 12 goes out, 2 stays in, right? A little bit of cheating, but it's a good cheat, right? Next one, 45. Same thing, right? If I start with 5, I can get a 9 here, but I know 9 is a perfect square, right? So 3 goes out, 5 stay in, okay? 540. 540, I can do a 2. That would be 270, right? I can do 2 again, so that will be what? 130. I think we did this question, right, before. 5, right? And then that will be 3, 3, 3. So we have a pair of 2, pair of 3, right? I think this one is an example on the top, right? Yeah, 540 on the top. But then this time is a square root, so we can only take pairs out. Okay, next question, question F. We can use 3. Right, and then I know 100, I can make it into pairs of 10 and 10. And that clears everything, right? So 10 can go out, right? 3 stay in. Perfect so far, right? Everyone's good. And then 90, I'm going to use 10, right? Even though 10 is not a prime, but because I know 10 is only 2 and 5, right? So I just remember that, okay? Keep that in mind, 10 is 2 and 5. And you're left with 9. 9 is a perfect square. So 3, 3, 2, 5. So only 3 can go out, right? 2, 5 can stay in. So that's correct. Okay, 54. Kind of like 540, right? So 2, 27, and then 3, 9, 3, 3. This is a cube root. So remember you need triplet. So don't forget the cube root, right? Okay, question I is the one that we have different answer. So let's look at how we break down 108. So we'll start with the prime, okay? So 2 will be 54. Oh, 54, and we saw it the third time today, right? So 2, 27, 3, 9, 3, 3. This is a cube root, okay? I hope you didn't confuse with the cube, right? With the 4. So this 3 is with the cube root. So you need triplet. Okay, so the triplet, the only triplet we have is the 3. So 3 will go out and meet the -4. Okay, so it should be -12 on the outside and 4 stay in. Okay, Eric, do you see a mistake?
Yeah, I accidentally put 9 there instead of 3 because I forgot to. Yeah.
Yeah, okay, so your 9 is not a prime yet, so you have to continue break it down. Okay, question J, 250. So you get 2, 1, 2, 5, right? Okay, 1, 2, 5, if you remember, is 5, 5, 5, right? It's a perfect cube. So I can take 5 out. Okay, 1, 2, 5 is made up by 5 to the cube. That's a triplet here. So 5 goes out, meets with the 2 that's already waiting, right? So makes it 10. You're left with the 2 inside. Right, 64. 64, I can use 2, so 32, 2, 16, 2, 8, 2, 4, 2, 2. Okay, so we have total of 1, 2, 3, 4, 5, 6, right? 6 of them, but we need, how do we call this? Quadruplet, okay? So this one need 4 of them, right? To go out. So 4 of them go out, you're left with the 2 2s on the inside. Okay, that's correct. 32, we can borrow the result we got from here, right? Use that. So it's like starting from here, right? Because you have a 32 there. So you can get 4 twos to go out, right? A group of 4 twos. And instead of 2 twos inside, we have only 1 2 left inside, right? So you look at question K, right? So answer is correct. Okay, now we got to the number part where most people have trouble, right? But the idea is the same and actually should be easier because you already know how many things is already factored. So like 75, okay, the only thing we need to break down is 75, right? That's the only number. So let's use 5 and then 5 again. So you get pair of 5. So we know 5 go out, so that's correct. Now you look at the exponent. You have 5 x's. So that makes 2 pairs, right? 2 pairs of x and 1 more, right? It's like you divide by 2. 5 divided by 2 because it's a square root, so we need to divide by 2. The answer is 2 with a remainder of 1, right? So this 2 here tells you you can have a square on the outside. And then the remainder of 1 tells you you will have 1 left over on the inside. Okay, if you want a rule like that, right? But you got to understand why we do that, right? You can have 2 pairs and 1 alone. Okay. Same thing with the cube. You can have 1 pair, so you get 1 outside and then 1 inside, right? 1, 1. The z, right? You get 2 pairs. Oh, so that should be a square then, right? Yeah, Sarah? So the z, right? If you take 4 divided by 2, you get 2 pairs. So the z should carry a square, right? So, and then no more z on the inside because there's no remainder. Okay? So we do the same thing for the other ones. So question N. All right, so Nathan, how do you break down the 108?
You could do it to like 2 first.
Yeah. So 54. Go on.
And then you could do another 2.
And then?
And then you would do it would be 27, so then you go 3. And then you do another, and that'd be 9, so you do another 3.
Mhm.
And then you, yeah.
Okay, so continue from there. What goes out now?
The pair of 2s and 1 pair of 3s.
Very good. So what number will be outside then?
6.
6 will go out.
Actually, no, 2.
2 will go out.
And 3 will go out.
3 will go out and they meet with
2.
so together will be
12.
Yeah, okay. Now let's start with the letter, okay? On the inside we have the M. So how do you make the M go out?
The N.
M. M.
You just have, oh, the M. I think you could take the whole M out.
Yeah, so what should be outside then?
M4.
Yeah, very good. Okay, now let's go to the N.
Okay.
Yeah, so what will go out?
Pretty sure you could take like a.
How many pairs of N?
Can you take 7 pairs?
Yeah, and then it will go out and meet with
the other n.
Yeah, so together will be n to the,
15,
no,
8.
yeah, it will be 8. Okay, because each pair only goes out, become 1, right?
Yeah.
Okay, just like the pairs of 2 that goes out, but only 1, 2 on the outside. Okay. Right, so we have P, that's nothing to join, right? It just stay, so that's everything on the outside. So what should be left on the inside then?
3,
Yeah, there's a 3.
and then n.
Yeah, N, okay? Everything for the N went out, but N has still have a single N on the inside. Make sense? Okay, do you understand now?
Yeah.
Okay, yeah, finish N and O, okay? Eric, are you done question O?
I just finished questioning.
Question
I'm still
O?
working on it. Yeah, I'm still working on it. I'm almost done.
Okay.
Yeah.
Right, so same with Nathan, okay? When you finish question O, okay, Eric and Nathan, you can raise your hand, okay? And then we'll go over. Remember, this one is a cube root, okay? So you need triplet, group of 3 to go out, okay? This is not a square root for question O. Okay, Nathan, do you have any trouble with O?
No.
Almost?
Yeah, I'm almost done.
Okay.
Jason, I'm done.
Okay, what's your answer?
4x squared y5 z5 to the cube root of 4x squared.
That's all, right?
Yeah.
Yeah, okay. Eric, what's your answer?
I have 16x for y6 z6 and then square root of y.
Cube root. What's inside a cube root?
Oh, sorry, I read it as z to the power of 3.
I said that many times. Come on, Eric, you gotta pay attention. Okay, I even wrote it on the sheet, right? It's a cube root. Okay, Eric. All right, so let's check. Aaron, what's your answer look like?
It's the same.
Same, yeah. Brendan?
It's the same.
Okay, looks good. Okay, so let's break down very quickly 256. So 128, 264, 232. Okay, and then 216, 28, 24, 22. So we need cube, right? Triplets. So 1, 2, right? 2 group of 2, so that makes the 4 on the outside. And then at the same time, you can write down whatever that's left over, right? So you have a leftover of 2 2, so that's a 4 on the inside. So far good. And then for the x, you can have 2 groups of 3s, right? So x squared, yeah. 2 groups of x. And then for the y you could have 3 groups of 3 y's. And so everything, all the y will go out, right? So that makes the y to the 5. And for the z, you could have also 2 groups, right? So when they go out, oh, z to the 5. Shouldn't be z to the 5. Everyone got the same? You guys got confused with the cube root. Right? What should be outside for the z? Z to the what?
3.
Yeah, it should be 3, right? Not 5. Okay, because you get 2. Okay, 2 groups of triplet from the z. Right? For the z, you get z squared to go out, join with z to the 1. Okay, outside only has 1 z outside, right? So it should be z to the 3 only. Okay, so that cube root is throwing a curveball at you, right? So the only leftover is x squared. Okay, so be careful with that, x squared. Okay, so that's all. So we'll have a break, 15 minutes, and I'll see you guys back here at 11:20. Okay.